Hello, everyone, and welcome back to a mind blowing journey into the world of AI, machine learning, and data science. And today, get ready to unlock the secrets of neural networks as we see what are neural networks and how neural networks actually work. So, before diving into that, what exactly are artificial neural networks, we must understand from where that idea actually originated. So, this idea actually originated from the human brain. As we guys already know, that our human brain has lots of neurons. And whenever we do any particular task, a particular set of neurons are triggered in a human brain, which enables us to do that particular task. So, here is an image of an biological neuron. So, what happens is the information, whatever input is we give, like we are looking at a particular thing, or we are driving, right? We are receiving input, suppose through our eyes and through some sensory input. We pass all that information through dendrites to a biological neuron, and it checks in that if that value is increases a particular threshold value, then that information is flown to that through that neuron to another neuron through axon. Okay, and if the threshold value is not reached, then that next neuron is not going to get fired. So scientists thought, can we make use of that same principle and can create an artificial neuron which can help the computers learn better? So yes, this idea was actually originated in 1940, guys. And in 1957, a single layer perceptron model was originated. So let's see how that perceptron actually worked. Let's see what happens exactly at a single neuron. So we can think of a neuron like it will hold a single value. Okay, but how? Suppose we are having multiple inputs. Suppose we are having x1, x2, and x3. Okay. Initially, what we do is we multiply those input values with a random weight values. Suppose I'll multiply x1 with w1, x2 with w2, and x3 with w3. And what I will do after that, I will add a simple bias value to that. Bias will help us with the threshold later on. Okay, once I have done that, what we'll do is we will pass that information through an activation function. So you guys must be wondering what exactly are activation functions. I'll not be diving in detail about activation functions as I want to create a separate video regarding that. But you can understand that it actually helps our model in learning the non-linearity. Whatever non-linearity is in our data, we want our model to learn that. What is non-linearity? Suppose I am doing an image classification problem. And we know like our images are not a linear problem, right? It's a complex thing. It's a kind of non-linearity to it. And we want our model to learn that. For that, we add an activation function to it. So there are different kind of activation functions. Like we have a sigmoid activation function, we have tanh, we have rectified linear units or the ReLU. So in sigmoid, what we do is whatever information we are getting it makes sure that the value is in between 0 and 1. And in tanh, it makes sure that the value is between -1 and 1. And in ReLU, it's between 0 to that particular value to that infinity. So now we know what happens at a single neuron. But what if we have multiple neurons and we connect it? So this is how a neural network or a deep neural network comes into the picture. And this is how it looks like. We have an input layer, and then these two are the hidden layers, and at last we have the output layer. And you can also see that that single neuron is actually connected to all the neurons in the another layer. So that is a fully connected neural network. Okay. Let's also try to go through an example, a simple example, to make us understand how it actually works. Suppose we want our neural network to recognize or classify a handwritten character digit. Like what I want is, suppose I give my neural network a handwritten character digit such as 3 or 4. I want my neural network to classify that number is 3, that number is 4. So first of all, we have to make sure we are giving a network a proper input. For that, what we will do is, we will, as we know that image is nothing but pixel values with the range between 0 to 255. So we can flatten that into a single array, and that all those values going to be the input to my neural network. So here, those are the input to the neural network. And at each neuron, that particular thing is happening that we discussed above. That is input times weight, add bias, and passing through an activation function. And at the end, it's going to give some value at the output layer. So once we have that value, so our main goal is, okay, but we want our model to improve, right? So how we can do that? We first of all have to calculate the loss value. So for we can you make use of many loss functions, right? But mainly what we do is we use a mean squared error. We check the real value and the predicted value, and we calculate the loss. So once we have the loss at the output layer, our goal is to improve the whole network. So how we can do that? So what we have to do is we have to go back into our network and make changes into those weights and biases. You remember, right? Yeah, you must remember, guys, that the weights and the biases are the randomly initialized values that we selected above. Okay, so we can make changes to that. Okay, so how we do that? We make use of the partial derivative. We do the partial derivative of this loss value with the weight and the biases, and we make use of the chain rule of partial derivative to flow that information in my whole network so that all the weights and biases are updated accordingly. And this whole process continues, guys. So when we go from left to right, that's a feed forward. We are feeding forward, right? And then when we go back and we changes the weights, that is known as back propagation. So it keeps on going like this. It goes from left to right, it makes a prediction, and then we check the loss value. We go back through partial derivatives, we tweak the weights and the biases, we go back, then again we come forward, computes the loss value, and this process continues, and hopefully our model starts improving. And few more terms come into the picture, like what are dropouts. So dropouts is nothing, guys. In that, what happens is we are actually preventing our neural network to overfit. We don't want it to remember all the information. So for that, what happens is few of the neurons are disabled in my neural network, and we force our neural network to find new pathways to learn. Okay, so it can generalize that information rather than just remembering whatever that is. We are trying our model so to prevent overfit also. So this is how the whole neural networks work. And also the one more term comes into the picture, that is a learning rate. So what is a learning rate? So we are updating our weights and biases, right? But how much value we should make changes to that? Is that a big value, a small value? So for that we have something called as minimum global cost minimum value we want to reach. Okay, so if the value is very large, what will happen is there is a chance that we might miss this local minima point and we might overshoot that. Okay, and our model will not be able to improve in that situation. Or if we have a very less value, it might take lot of time to actually reach the minimum value. So the best way is to select a value which is neither that big nor that small. So now we have a good understanding, right? So what is a neural network and how it actually works, and the terminologies such as feed forward, fully connected neural networks, back propagation, and dropout layers. And what happens is, as we have different kinds of problems, right? Image classification, voice recognition. So for all these things, we have made changes to these neural networks which can help in those particular tasks. Such that for image classification, we have convolutional neural network. For sequence to sequence problems, we have a recurrent neural network or long short-term memory, or something for ChatGPT like model, we have transformer and attention mechanisms. So yeah, these are the different kinds of varieties of neural networks that we have. So yeah, that's all for today's video, guys. And I hope that you found it informative and gained a better understanding of how neural networks work. So don't forget to like the video, subscribe to our channel, and hit that notification bell to stay updated. So thanks for watching. So see you in the next video, guys. Bye bye.